Hello everyone, we are team number 1 and today we are going to present our STEM project that is name is Closing. My name is Martin Flores.
My name is Juana Migueles.
My name is Ian Vasquez.
My name is Jose Lopez.
My name is Yaretsi Lopez. My name is Natalia Flores.
To introduce you all to FlowSync. FlowSync is an anti-traffic light designed to optimize vehicular flow in intersections through real-time sensors that detect all these patterns. Unlike conventional fixed traffic signals, our project FlowSync dynamically adjusts green and red light intervals in response to actual vehicle density detected at each assignment, minimizing overall congestion and traffic jams. The motivation behind this project is that a major problem in cities is that traffic jams, light cycles fail to adapt to traffic patterns throughout the day, and these causes lead to fuel waste, increased emissions, and more indirect problems that can affect the overall flow of the traffic.
These are the SDGs related to our STEM project. 3. Good health and well-being. 4. Quality education. 7. Affordable and clean energy. 8. Decent work and economic growth. 9. Industry, innovation and infrastructure. 11. Sustainable cities and community. And finally, 13. Climate action. These SDGs are related to our STEM project, that is the FlowSync, because the FlowSync is a traffic light that aims to improve the traffic conditions in big cities like Monterrey, and we are showing how.
This is our first prototype, a traffic light designed with Tinkercad and Arduino configuration. We analyze distance and displacement by measuring the total travel distance of vehicles and their movement per cycle. We also study velocities, including average speed and deceleration when vehicles approach red lights. Forces are also considered by estimating the braking force applied during signal changes. And finally, we measure energy consumption by calculating the electrical energy used by LED lights and comparing adaptive FlowSync mode with fixed cycle systems. Our prototype is based on a rectangular intersection layout representing the meeting of two perpendicular avenues. The lanes are designed as parallel straight lines to simulate uniform rectilinear motion, allowing vehicles to follow predictable paths. The intersection forms a precise 90-degree angle, creating a perfect cross to measure traffic flow accurately.
Our prototype represents a small urban intersection. It includes streets, pedestrian crossings, buildings, and vehicles to simulate a real-world environment. Our project theoretical framework starts with basic physics like dynamics and kinematics. We treat traffic like a flow, where congestion depends on how many cars there are and how fast they move. Using Newton's second law, the system calculates how cars speed up and move through intersections. Instead of fixed traffic lights, our system changes depending on how much traffic there is. This helps reduce traffic, save time, and reduce CO2 emissions. Other systems like SCADs and AI technology show that smart traffic control is possible, and it is the future of cities. Our prototype uses a simple intersection to model car movement. By measuring traffic and speed, FlowSync helps create a more efficient and less polluted city.
Here we have the variables for our prototype. I'm going to explain a little bit this table. We have the physical variable, the symbol, the units, and the expression of purpose. First we have the time of waiting, that is the measure of how long the cars are waiting on a red light. Then we have the displacement, that is the fixed distance of the intersection lanes. Then we have the velocity or speed, that is the measure of the flow speed to determine how quickly lanes clear. Then we have the vehicle accumulation, that are how many cars are waiting in the intersection. Then we have the green light duration, that is the one variable that we are going to change based on the vehicle flow. And then we have the acceleration, that is the velocity of how quickly an intersection clears with our prototype.
For STEM project, we made a table with the additional instruments we used based in data of traffic in Monterrey. First of all, average congestion level and the peak hour congestion level. They reaches values of 40% and 142% being our baseline for mission system reduction, and the target period for dynamic adjustment. Also, the annual time loss per driver, the main problem we aim to solve with this project, reaches the amount of 89 hours annually. It's a very concerning amount. I'm repeating, the main problem we aim to solve with the project. The peak hours average speed reaches the low quantity of 21.2 kilometers per hour, and the physical variable we use for flow manipulations. And the environmental justification of our project is the poor air quality, reaching the high and concerning value of more than 180 days annually. We also made a table with scales from 1 to 5, measuring different metrics and the status of each, like the driver's stress level, like the perceived efficiency, safety perception, visual signal clarity, and also the environmental concern. Beginning from the first one, we have a critical score of 4.6 out of 5 from driver stress level, being result of the high amount of hours lost. Also, for the perceived efficiency, we have a very low score of 1.8 out of 5, a low score for safety perception, being 2.4 out of 5, almost the middle, and a moderate status for visual signal clarity with 3.2 out of 5, and environmental concern with a high, also reaching critical status, a score of 4.1 out of 5 in the environmental concern.
To summarize, the FlowSync project successfully demonstrates how kinematic principles and fluid dynamics can optimize urban mobility, directly supporting SDGs 11 and 13 by reducing downtime and CO2 emissions. Our data analysis confirms that dynamic adjustments based on traffic flow are significantly more effective than fixed time systems, reducing average wait times by over 40% and resolving initial problems of congestion, time, fuel waste. When the prototype effectively demonstrated our hypothesis, its performance could be further improved by integrating AI-powered sensors for real-time automation and solar panels to ensure energy independence, making it an scalable solution to the traffic crisis in cities like Monterrey.
Developing the FlowSync prototype has been a learning experience that helped us understand the technology and how it can be a solution of everyday problems. Through this process, we obtained crucial information on how to apply kinematics and Newtonian laws to synchronize urban traffic flow. The key result was the prototype's ability to eliminate unnecessary downtime. This project demonstrates the effectiveness by comparing existing data with hypotheses previously formulated in the research. And it is also a replicable model for cities to improve people's quality of life. This is the logo of our STEM project, so I made it inspired in the conventional traffic lights, and it has 3 happy faces to represent the development of the systems of the normal traffic lights, and it has a slogan that is the logic behind the movement. And also we use apps that we learn how to use it in class, like Tinkercad. In Tinkercad we made the program of our Arduino to do the traffic light in our prototype, so the knowledge that we achieved in Introduction to Robotics is also like part of our STEM project. And not only that, also like management forms and spaces, English in action obviously, and science of movement.